Bismillah ar-Rahman ar-Rahim. What I will do in this section, I will solve the questions related to chapter 1, which appears in the final exams, all final exams, from term 211 to term 231. So this is like can be considered as a review of chapter 1. So we solve different problems related to chapter 1. Okay, if the differential equations is exact, just to remind you, what's the meaning of exact differential equation? Means if we have m dx plus n dy equals 0, this is the differential equation, then to be exact, I need partial m with partial y equal partial n with partial x. Be exact. So we have this equation. I have what? G of x, y cubed minus 1 over 1 plus 9x squared dx plus x cubed y squared dy equal to 0. So this is m of x and y, and this is n of x and y. So it is partial m with partial y, with partial y. That will be, what's the meaning of partial m of partial y? Means I need to differentiate. With respect to y, I consider x as constant. So g of x is just a constant. What's the derivative of y cubed? It will be 3 g of x y squared. Now this is constant, so this is 0. And that should equal to partial n with partial x. And that is what? 3x squared. I'll consider y as a constant here. Y squared is just y squared. So x cubed, derivative is 3x squared. We compare these two, very clear that g of x should equal to x squared. What they want g at 1. G at 1 will be 1 squared, which is 1. So this will be my answer. Okay. The solution of this differential equation. One of the methods, if you remember, if you see ax plus by plus c in the differential equation, so you let u equal ax plus by plus c, and then you proceed. So very clear, I have x plus y plus 1. So I let u x plus y plus 1. Now I need dy over dx, so I need to differentiate this with respect to x. So I have dy over dx, that will be 1 plus dy over dx. This is what I'm looking for. So dy over dx is what? Du over dx minus 1. Okay, plug everything in this differential equation. So this differential equation becomes what? Du over dx minus 1 equals x plus y plus 1 is u, that will be u squared. So I have du over dx equal 1 plus u squared. In other words, I have du over 1 plus u squared equal dx. Now this is separable. If you remember how to solve separable differential equation, just we integrate. So I have what? Tan inverse of u equal x plus c. So it will be u is equal tan x plus c. And what is u? I have x plus y plus 1. This is u equal tan x plus c. If we look at the answer, it's y equal. So let me write it y equal. So y equal minus x minus 1 plus tan x plus c. And that will be my answer. Okay, the solution of this equation, he says it's exact. How to solve exact? If you remember, exact means what? Means I have partial f, the differential equation, partial f with partial x dx plus partial f with partial y dy equals 0, which means d over dx of f, give me 0, the differential. Yeah, the f over the x. I mean, the complete derivative, df over dx is partial f with partial x dx plus partial f with partial y dy. So it means the solution means that f equals c. That will be my solution. This is what I'm looking for. So I need to find f which satisfy that this is partial f with partial x and this partial f with partial y. But how to check it's exact? We need this. This is how to check it's exact. But how to solve it? As I said, I need to start. If I write the differential equation, m dx plus n dy equals 0, I need to start with partial f with partial x equal m, and also I have partial f with partial y equal n. I start with this one or that one, it's up to you. And then after that, you will find f with a constant, either function of x, either function of x or function of y. It depends. You start with one, then use the other one to find that constant or that function of x or function of y. Okay, you can start with one of them. Let me start with this one. I think it will be easier. Or both are okay. Okay. Now partial f with partial y is 2xy plus x squared minus 1. That's the meaning of it. So what will be f? F of x of y. Now I will integrate with respect to y. So consider everything related to x as constant. So I have 2xy, or I say x times 2y. What's the integral of 2y? Is y squared. So I have xy squared. This one constant, so x squared y. Constant minus y. Don't forget you have function of x. Usually they write it h of x. Okay. Now I'll use the other one. I use this one to get f of xy, but there is a constant function of x. So I'll use the other one to find what is h of x. So I have partial f with partial x. Do the calculation here. I have y squared plus 2xy. This is constant plus h prime of x. That should equal to what? To m of x and y, which is x plus y all square. What is this? This is x squared plus 2xy plus y squared. So I compare this with this, we're getting what? H prime of x equal what? X squared. And this is checkpoint. This should be only function of x. If we use the other one, then I get the constant function of y only. That will be h of x equal x cubed over 3. So what is f of x and y? Just I will put h of x. I have this. Just I will plug h of x. So I have x y squared plus x squared y minus y plus x cubed over 3. Now, what is my solution? My solution, as I said, the function is equal to c. So I have x y squared plus x squared y minus y plus x cubed over 3 equals c. Now, he gave me initial condition to find the c. Okay. So that gives me what? Y at 1 equal 1. That gives me what? I have 1 times 1. That is 1. 1 times 1. That also 1 minus 1 plus 1 over 3 equals c. So this is cancelled. So c equal 4 over 3. Okay. So we have what? This will be the solution. Oops. That will be x y squared plus x squared y minus y plus x cubed over 3 equal 4 over 3. And he wants us to find what? He now wants us to find y at x equals 0. When x equals 0. So substitute 0. I have, we say at x equals 0. We have what? This is 0, 0. So you have 0 minus y. This is 0 also, equal 4/3. So y will be what? Y will be minus 4/3. And that will be my answer. Okay. By using this substitution, differential equation can be transferred into what? Okay, so I want to transfer this differential equation into another differential equation using this substitution, which they're talking about homogeneous. If you remember, if it is homogeneous, then I will let y equal ux, or x equal vy, if you remember. Okay, so let me write this equation in the format, in the usual format, mdx plus ndy equals 0, to see it. So I have what? I have, yeah, this is I have take x squared dy over dx to the other side. That equal to xy plus y squared plus x squared. So what we have? We have xy plus y squared plus x squared dx minus x squared dy equals 0. Okay, now I write it in this format. Usually I like it to be in this format, so it's easy to deal with. I notice this is homogeneous. How to check the powers? This is 2 powers of x times y. X to the power alpha, but if you remember, we check f of t alpha, t to the power, yeah. If I put instead of x, t to the power alpha and y to the power alpha, I'm getting the same power. I check f of tx, ty is equal, yeah, t to the power alpha, f of x and y. If it is the same alpha, then it's homogeneous, if you remember. Now actually check the powers. Here is 2, here is 2, here is 2. So this is homogeneous of degree 2, and this is homogeneous of degree 2. If both m and n, they are homogeneous with the same degree, then we got homogeneous equation. Now, he told us, use this substitution to do it. So if I let y equal ux, what will happen to dy? dy will be u dx plus x du. So plug it here. What you have? Now the differential equation becomes what? X, y is ux. Let me do it in details. X times y plus y squared, which is u squared x squared plus x squared dx minus x squared. This is dy u dx plus x du. That should equal to 0. What I did, only I plugged this and this. I plugged these two into the differential equation. See what will happen. I have ux squared dx plus u squared x squared dx plus x squared, be careful now to check it, minus ux squared dx minus x cubed du equals 0. If you notice, this cancelled with this. Now put the one with the dx in one side and the one with the du in another side. So I have what? You have, yeah, let me do it in details. U squared x squared dx plus, I can take dx common factor. Yeah, plus x squared times dx. That will be x cubed du. Okay, I can take x squared common factor here also. So I have x squared, u squared plus 1 dx equal x cubed du. Okay, so I can simplify this. I want the x in one side. If you notice, u in one side, x in one side. Everything is like that. Okay, so I have what? Yeah, I divide by x cubed. That give me dx over x and I divide by u squared plus 1. That will be du over u squared plus 1. I read it this way or that way, it's the same. So this is my answer. Okay, if the differential equation is exact, we did something like that before. So you have m dx plus n dy equals 0, when that will be exact. If partial m, partial y, this is x, this is y, equal partial n with partial x. Okay, so this is my m, this is my n. I have partial m with partial y. I differentiate with respect to y, I will consider x as constant. So I have 6xy cubed, that will be 6. No, I have 6x is a constant, so I have y cubed is what 3x squared, 3y squared. That will be 18xy squared. This is cosine of y, so that will be minus sine y. Then what is partial n with partial x? I consider now 2k y squared, these are constant. What's the derivative of 2x? What the derivative of x squared is 2x, so I have 4k xy squared. And here, sine y just a constant, that will be minus sine y. These two, when they are equal, very clear. I have 18 equal 4k. So k will be 18 over 4, which is 9 over 2. And that will be my answer. Yeah. If c is a constant, solving this equation. Yeah. First, I need to figure out this equation is which format or which method shall I use? Yeah, one of the things which is you should notice that I have e to the power xy dy over dx is minus y. This is 3 e minus 2x is minus y. Yeah, very clear that I can separate them because I can take e is minus y as a common factor. I have what? 1 plus 3 is minus 2x. And here I have e to the power xy dy over dx. Okay. So multiply by e to the power y. I have y e to the power y dy in one side. And this, take it to the other side with this one. So I have what? E is minus x. 1 plus 3 is minus 2x dx. Yeah. So it's very clear that is separable. Okay. Now I integrate. This one I need integration by parts. If we do integration by parts, you will get this. Yeah. Do the integration by parts, you can check it. So I have what? Y e to the power y minus e to the power y. Or before that, let me simplify the other one to make it really e to the power y dy equal what? E is minus x plus 3 is minus 3x dx. So you have now integrate to get what? Y e to the power y minus e to the power y. This is the integral of this. What's the integral of this one? Minus e is minus x. What's the integral of this? Minus e is minus 3x. Easy, you can check. Differentiate this, you'll get this. Differentiate this, you need the 3 plus, plus c. You want everything equal to c, so I'll let everything in one side and c in the other side. So I have what? Y, ey, minus ey, plus e is minus x, plus e is minus 3x. That is equal to c, and that is my answer. Okay, let me do more. Y dx minus 4x plus y to the power 6 dy. Yeah, this is tricky. If you look at the answers, you have everything x mostly. One is y, but usually you have x equal. If you remember, now I need to remind you about the linear differential equation, how to rewrite it. You have dy over dx plus function of x times y equal function of x. Yeah, we could write this, I think. G or something, I forget. Yeah, g of x, and this is f of x. Who cares? This is the linear. Where, how to solve it? I have integrating factor, e to the power, integral of g of x dx, multiply everything, then you have, this is differential. So this multiply, then multiply the integrating factor. I'm just trying to remind you how to solve. This is linear, huh? Differential equation. This is the format. And then you have this integrating factor, call it u, or usually call it mu. Multiply the differential equation by mu. So you have mu of x dy over dx plus mu of x g of x y equal mu of x f of x. The idea in this side will be d over dx of mu of x y, and this is u of x times f of x. Oops. Times f of x. So now integrate, you'll get mu of x y equal the integral of that. And then solve for y. Yeah, this is the linear differential equation. If it is, linear with respect to y, linear in y. This is a little bit different. This is linear in x. So what I will do, I will rearrange it. Now, if you notice, this is linear in y, just to remind you. Now, this problem is linear in x. Linear in x, which is the same thing, but now I'll reverse everything, huh? So I have dx, this is the format, dx over dy plus function of y, x equal function of y. Okay, so I have my integrating factor, mu of y, which is the integrating factor, we call it. It will be e integral g of y dy. Multiply it. So this side, the same idea, multiply by mu of y now. So I have d over dy of mu of y times x equal, the other side will be mu of y, f of y. Integrate, you get the answer. Okay. And this is what happened in this case, and you just rearrange it. You have y. I notice it's not linear in x, because linear in y, because they have y to the power 6. So that will not be linear. But x, I notice it's only linear. So that's what make me think of it as linear in x. Okay. So I have y dx, let me rearrange it, equal 4x plus y to the power 6 dy. Okay, now divide by dy. So I have y dx over dy equal 4x plus 4y to the power 6. I'm trying to get in details, huh? So rearrange it. So I have y dx over dy minus 4x equal 4y to the power 6. Divide by y now. So I have dx over dy minus 4 over y x equal 4y to the power 5. So it's very clear in this format. I have the x over dy. This is function of y, and this is function of y. So it's linear in x. Okay. Now I'll do the procedure. What is the first step? Find the integrating factor, which is e to the power g of y dy. Everything in terms of y, huh? So e integral minus 4 over y dy. That will be what? Yeah, minus 4 len y. Which is y to the power minus 4. Okay, so that's my integrating factor. Multiply everything by y to the power minus 4. So you have y minus 4 dy, dx, sorry. Dx over dy minus, this is y is minus 1 minus 4, y is minus 5x equal 4y. Okay. Now, this, as we said, should be in this format. So d over dy of this y is minus 4x equal 4y. Actually, you can take it as a checkpoint. Now, what's the derivative of this with respect to y? It will be minus 4y is minus 5 times x plus, because it's the product rule, plus y to the power minus 4, derivative of this, dx over dy. So these are two are the same. Okay. Now integrate, you'll get what? This is خلاص y to the power minus 4x. What's the integral of 4y with respect to y, huh? I have 2y squared plus c. I'm looking for x. So multiply by y to the power 4. I have x equal 2y to the power 6 plus c y to the power 4. Which is this? This is my answer. Yeah. He told me now this is homogeneous. If you remember, we said for the homogeneous, either I let y equal ux or x equal vy. Yeah, if you notice, I think since I need dy or dx, dy equal u dx plus x du, or yeah, just to remind you, x equal v dy plus y dv. And instead of plugging this, so I have 2 terms times 2 terms, make it complicated. I notice if I use dy, then it will be easier in the calculation. So I'll use y, huh? I let y equal ux. That implies dy equal u to x plus x du. Plug it now. What you will get. Instead of y, I will write this. Instead of dy, I will write this. Okay. So I have x uy, which is ux dx plus x dy, which is u dx plus x du. Now I have only x and u. Now we'll try to solve this equation. I have x dy, which will be separable for sure if it is homogeneous. Now this is minus ux dx plus xu dx plus x squared du is equal to 0. Okay. So these two cancelled. Yeah, nice. So I have, yeah, let me take it easily. X dx equal minus x squared du. In other words, I have what? Yeah, dx, yeah, minus dx over x equal du. Okay. So, yeah, I divide by x by minus x squared. Okay. So I have minus len integrate absolute value of x equal u plus c. Okay. Don't forget what is if y equal ux, what will be u? Y over x. Plug it here because I need to write everything in terms of y and x and y. So I have minus len absolute value of x is equal u is y over x plus c. So multiply by x, you get what? Minus x len absolute value of x equal y plus cx. Okay. So I have y equal what? Minus len absolute value of x minus cx. Yeah, minus cx plus cx, it will not make a difference because I can call minus c another c plus c. call minus C, call it C1. So this is minus ln absolute value of x plus C1x, which is call it C. So this is only my answer. Yeah, this is true or false. The first order differential equation is not separable. Is it true or false? It's separable. Why? Because if you look at it deeply, you have what? You have r theta plus 1 plus theta plus 1. Separable means what? I can separate the two variables with their derivatives. So you have what? This is r plus 1 times theta plus 1. This is the r by d theta. So I have what? The r over r plus 1 equal theta plus 1 d theta. Very clear, this is separable. I have r in one side, everything, and theta in one side. So is it not separable? No, this is false. Yes. The linear differential equation, where k1 are non-zero constant, possesses a constant solution. Can have a constant solution. The only conditions, k1 and k2 are non-zero. Okay. What's the mean constant solution? I have y equals c is a solution. How to check that is true or not? Substitute. So I have y prime equals 0. So it will be the differential equation. Just substitute into the differential equation. I get what? This is the differential equation. Let me write it here. So 0 plus k1 c equal k2. So that means if I take c, k2 over k1, which is, it can't be since k1 not equal to 0. If I take c this, then it will make a solution. So consider c equal this. So this is the solution. So y equal k2 over k1 is the solution. So there is a constant solution. So this is true. That was true or false statement. Remember, in one exam, we brought this. But in our exam, we don't have true or false. We have only multiple choice. Okay. The solution of the linear differential equation with y of 1 equal 5 is x equal. X equal. Okay. Yeah, it seems also this one is linear in x. Actually, it's more arranged than the previous one. I have the x over dy minus 1 over y x equals 2y. Yeah. Yes. So now it is very clear, linear in x, like this one. Or is it like this one? Like this one. So what I will do, will be my gy. I'll find the integrating factor, which is a integral of g of y dy. That will be a minus 1 over y dy, which is y to the power minus 1. Multiply everything by that. So you have 1 over y dx over dy minus 1 over y squared x equals 2. This should be this way, d over dy y minus 1 x equal to 2. Check. That will be 1 over y dx over dy, this one. And then derivative of this minus 1 over y squared times x, which is this one, which is correct now. Integrate. So I have what? 1 over y x integrate with respect to y. That will be 2y plus c. So I have x will be 2y squared plus cy. That will be my answer. Oh, but he gave me initial condition. Y at 1 equal 5. It means x equal 1 implies y equal 5. Plug it into the equation to find the c. So I have 1 equal to 5 squared plus c. Since y is, no, plus 5c. Plus 5c. So I have what? This is 550. Take the other side. So I have minus 49 equal 5c. So c equal minus 49 over 5. Yeah. So it will be my answer. So solution x equal 2y squared minus this strange number, minus 49 over 5y. So this is my answer. Okay. Let me do more. The solution is this. Then there exists a c. Yeah, this is linear. Is it? No, it's not linear. This will be what? Yeah, divide by x. I have dy over dx plus 1 over x y equal 1 over x y is minus 2. Yeah. If you remember, this is what? This is Bernoulli. How to do that? I will let, yeah, Bernoulli with n. What is the format of Bernoulli? Just to remind you, dy over dx plus function of x y equal another function of x y to the power n. How to solve it? Let u equal y to the power minus n. Substitute, you will get linear equation, and then solve it as a linear. That's mainly the idea. Okay, let us do this. I have n equal minus 2. So u equal y to the power 1 minus minus 2, y cubed. In other words, y to the power 1 over 3, or let me say y. Take 1 to the power 1 over 3 as a power to both sides. So I have y equal u to the power 1 over 3. So it is dy over dx. It will be 1 over 3, u is minus 2 over 3, du over dx. Okay, now plug everything here. You will get what? You should get the linear equation. Let me see. 1 over 3, u is minus 2 over 3, du over dx. Okay, plus 1 over x, u, y, I mean, which is u to the power 1 over 3, equal 1 over x, y, which is u to the power minus 2 over 3, since I have it y to the power minus 2. Now, multiply this one. I want this to be constant. I mean, the coefficient is 1. So multiply by 3, u to the power 2 over 3. So I get what? I get du over dx. Here I have what? Plus 3 over x, u to the power 1 over 3 times u to the power 2 over 3, u to the power 3 over 3, which is u to the power 1. And that equals 3 over x. That's it. So this is what? This is linear. Very clear. This is linear. So I'll do integrating factor, which is e 3 over x dx. That give me what? Ln x to the that will be x cubed. Do the integration, check it. Multiply everything by this equation. So I have x cubed du over dx plus 3x squared u equals 3x squared. This, it should be a differential, that d over dx of what? Yeah, of the integrating factor times u. Check. 3x squared u plus x cubed d over dx, which is correct. That will be 3x squared. So integrate to get what? X cubed u equal integral of this, which is x cubed plus c. So it is u. That implies u will be equal 1 plus c x is minus 3. And what is u? U is y cubed. So I have y cubed. So I need everything in terms of x and y. cx is minus 3. And this is my answer. Okay. Yeah, I think we did a good number. Let me check. Let me do more. Okay. What is this? Yeah. Let me rearrange it first. So I have 3y squared plus 2x dx equals minus 4y squared. Don't rush it. 4y squared plus 6xy dy. Okay. So let me arrange it more. 3y squared plus 2x dx. Oh, he told me it's exact. That's good. Yeah. Plus 4y squared plus 6xy dy equals 0. He told me it's exact. It means partial m with partial x, which is 2. Partial m with partial y here. It will be 6y is equal this with respect to x, which is 6y. So he told me it's exact, so I'll solve it as exact. So I have this one is partial f with partial x, and this one partial f with partial y, and I'm looking for f. So I'll start with this one. It seems to be easier. Yeah, I can start with any one of them. So I have partial f with partial x equals 3y squared plus 2x. Now integrate with respect to x. So what's the integral of this? That will be 3y squared x. What's the integral of this? X squared plus function of y. The constant is function of y. Now I need to find that function of y by using the other side. So, sorry, that means f of x and y, yeah, integrate this with respect to x, so I have f of x and y equals 3y squared x plus x squared plus function of y. Okay, so now, what is partial f with partial y? I find it two ways. It's equal to this in one side, and just I differentiate this with respect to y. So I have what? 6yx, x squared gone, plus g prime at y, and that should equal to 4y squared plus 6xy, which is n of x and y. Huh? You call this m, we call this n. That's it. Now I need to look for g prime of y. These cancelled. Huh? So I have g prime of y equal 4y squared. So it will be g at y. Integrate this. You have 4 over 3y cubed. Plug it into f. So my f will be what? 3y squared x plus x squared plus 4 over 3 y cubed. What is my solution? F of x and y equals c. So I have 3y squared x plus x squared plus 4 over 3 y cubed equals c. So I have c equal all of this, which is this. So this is my answer. If c is a constant, then the solution. Very clear. This is what? Linear. Linear in y. Very clear. This is my g of x. And this is function of x. So it's very clear linear of y. So let me do integrating factor. I have e integral 1 over x plus 1 dx, which is x plus 1. Ln of x plus 1. With the e, it will goes to x plus 1. Okay, everything is positive. No problem to worry about. X should be positive, actually. Huh? X should be positive here. Okay. Now, multiply. So I have x plus 1, y prime, plus y equal ln x. This should be written in this way, d over dx, just to check. That will be x plus 1 times y. And this is ln x. Okay. Check. This will be x plus 1 y prime, which is dy by dx. plus derivative of this, which is 1 times y, which is this side, which is okay. Everything is okay now. Integrate. We have x plus 1 times y. Integral of this, integral of ln x. By parts, if we do it, it's x ln x minus x. So that will be x ln x minus x plus c. So it will be y will be x ln x over x plus 1 minus x over x plus 1 plus c over x plus 1, which is this answer. Yeah. Let me check this one, then I will stop. Then the solution of this exact differential, he told me it's exact. No need to worry. So this is, I make it partial f with partial x, and this one partial f with partial y. Then I think I will start with this one easier. So I have partial f with partial x is y squared plus y sine x. What will be f of x and y? Integrate with respect to x. So I have xy squared. Integral of sine is minus cosine plus function of y. I'll find this function using the other one. So we have partial f with partial y equal what? 2xy minus cosine x plus g prime at y. And that should equal to 2xy minus cosine x, which is n of x and y. So very clear, I have g prime of y equal this. Yeah, it's function of y only, and this is just a checking point. So I have g at y is minus tan inverse of y. So plug it in f. So my f, x and y is what? X y squared minus y cosine x minus tan inverse of y. Is that my solution? No. My solution is f of x and y equals c, which means what? X y squared minus y cosine x minus tan inverse of y equals c. This is my answer, which is this one. Yeah. Let me stop the recording. I think we have a good number of questions. Then I think I need another video later. Okay. Yeah, let me stop the recording. Thank you.